in this video we will study the clone graph problem, and it is a kind of problem that actually enhance your conceptual understanding regarding graph. And we studied OOPS to make user defined data types. So that's why we are having a predefined class. It is a kind of blueprint, and on that basis of the class we will be making our object, and these object considered as nodes of a graph. So that's why it is really necessary to understand the class, right? So the class has two things, int value and vector of pointers, and it is called as neighbor. The name of the vector is neighbors. And before jumping to the problem, we have to understand this. So let's suppose most of you have seen this, like pair int p equal to 2 comma 3. It means that I made a object p of class pair, and how it look like, it is just like this: 3 and 2. So this is the, I called this as first and this is second. And if I need to access this, then I will say p dot first, and if I need to access this, then I will call it this p dot second. So this will give me the value 2 and this will give me the value 3. So likewise, if I wanted to made a object of this node class, then how will I made that? So it is just like node star obj1. I am making two object. So new, and this is the name of this class. If the name of this class is Manish, then I will say Manish, and what kind of value I wanted to store, I should be having, let's say 5. Now I am making another object obj2 new node 7, right? So how will this obj look like? So it is just like this only, right? This is, it has two part. The part one has value and it has a vector of any size, right? It is called as neighbor, neighbors, neighbor. Now for object 1 the value is 5, right? And let's say the address of this object is 100x, and now I will create this. I mean, whenever I do this, so the one more thing is created, that is obj1. So it will store the address of this x. So now this obj will point to this address. So that's why this obj has a address 100x, and this container's address can be different. Let's say it has 500x address, right? So that's why when I do this, so these kind of things happen in the backend. Now let's say after this, I mean if I have to create the obj, so it is just like the similar, in the similar fashion, value 7, the same vector, and might be it has a address, let's say 102x. Now if I wanted to access this, then if I wanted to access this, then what I need to do, I will say obj2 dot value. This will give me the value 7. Now if I say obj2 neighbor, then this become the vector. I mean, I came to this point. If I wanted to push this one, if I wanted to push back, what kind of thing I can push back? Since it is a pointer type, so I can push the address. So I can push obj1 into this. So I will be having this 100x, and I can push many things. I mean, it doesn't have a limited limit. I mean, it can be expanded up to 1000. Like the constraint in the graph is given that you can only store 1000 nodes. So that's why we can, the size of this can be max to max 1000. So I hope you got it. Now we need to understand this thing. So we are given adjacency list as an input. What does it, And how this will work, let's say, and it is given that it is a one based indexing. It means this one has a neighbor, this one has a neighbor 2 and 4, and the second index has a neighbor 1 3, the third has an index neighbor 2 4, and the fourth one has a neighbor 1 and 3. Now these are like the virtual thing, they are not exist, the edges not exist. That's why like if I wanted to draw, so it is just like 2 and it has two things, the 1 and the 3. So it doesn't have the value 1, I mean it has an address of this one. Let's say it has address 550x, it has 50x, and let's say it has a address 20x, so it is just like 20x, right? So this is how our object, or I can say node, look like. Now we need to create a copy, and initially we are given a original. Original means like this one. So original is pointing to the starting of the graph. So original is like this. So original is this, and it has a address of this 50x, right? So with this help of this thing, we need to create a copy. We need to create a copy, the same copy, but it should be a deep copy. I mean the address of this one should be different from the address of this one. This one should not be having a address 50x, it should be of anything, and every node should have a different address with respect to the original one. So let's say if I made a copy and the copy is like this, the copy should be pointing to the starting of the clone graph, and maybe it has address 1000x, and I need to return that after completing this function. So how will we do that? Now it's time to look into this. Now, so how will we do that? Since we have to traverse all the neighbors, and when we need to traverse all the neighbors, then either we use DFS or BFS, right? Now let's say we use DFS. So first of all, how we will do that? Let's say first of all I will create a new copy of this one. And how will I create a new copy? So I will say new copy. How will I create a new copy of this node? Because I have the class, so I can make any number of objects. So I will follow that rule, this one. So I will say copy new node, and the value, the kind of value that I want it to have, it should be similar as the original one, but address should be different. Value should be similar. So I will say 1. It means I created, let's say this is a copy part, I created this one. So after this I will get it like this 1, and neighbor should be, since original has 2 neighbors, so it should be having the same neighbor. Now see, when I created this, so I got it like, and my copy is like this copy, and let's say it has the address 100x, it has 100x. Now I will start, since after creating this copy I don't have a neighbor, I mean the copied node 1 should have an address, should have a neighbor 2 and 3, but I don't have a neighbor 2 and 3 right now. So that's why I need to traverse the neighbor of original one, so that I can create the similar neighbor for the copied one, right? So I will traverse in the one's neighbor. Now I will start with first neighbor of 1, that is 2. Now I came to 2, right? Now I will again create 2, and it also have the same neighbor. And when I am creating a neighbor 2 when I was in 1, and I am creating a neighbor 2 for this, So I will store the address of this 2 in 1, I mean into this. So let's say it has 200x, so I should be having the address 200x in my this first node, right? Now I will do a DFS on this. So I will check into its neighbor, right? So 2's neighbors are 1 and 3. I will start with 1. As soon as I am checking its neighbor, I need to create that neighbor. But like if I check with the first neighbor of 2, then 1 is already created. So that's why I don't want it to create 1 again. So that's why the simple DFS will not work. We need to maintain a visited vector. And what should be the type of that visited vector? Let's say we consider it as Boolean type. So 0, 1, 2, 3 and 4. Initially I set it to the false. Why we are doing this? Because we don't want it to create the same copy again and again, because I already created one, and when I into 2 and if I visited 2's neighbor, that is 1, I need to create that one, but we don't want it to create that one. That's why we will make it. So again I start with 1 and I created that copy, and I will set it to 1 as true. Now I came to 2. Now I will check 2's neighbor. So 2's neighbor is 1, that is 1 is already true, right? Now I will check the second neighbor, that is 3. 3 is false, so I can create its copy. So 3, right? I created, let's say it has 300x address. Now and I will store that address into this second part. But before that I wanted to store this address. But how can I get this address? I don't have anything where I stored this, so that's why this boolean type will not work. Why? Because I wanted to set the address, I wanted to store the address of its neighbor. I mean I wanted to store the address of 2's neighbor, that is 1 and 3. When I am creating at the point of creation, I can store that address of 3, but it is already visited. So I wanted to have this, I wanted that 1 should be stored somewhere. So that's why this kind of boolean type will not work. I need to create a visited vector, but the boolean type of that visited vector should be node type. I mean the pointer type. It should store the pointer. So that's why this will not work, right? Now I hope you got it. If you are not getting it, I am writing the code and then I will be explaining line by line. So see, this is the function that we need to complete, right? So I'm writing the function node star clone graph Okay, so first of all I will create the copy. What kind of, how will I get the value of this original? See, this is original and I wanted to get this value. Let's say I am into this and I wanted to get the value 5. So how will I say? Obj this value, obj arrow value, right? So that's why I will say original value, right? I created this one and now I need to create the vector also, and the vector should have a pointers node star type. The vector should be pointer type and I will call it a visited, and constraint is saying that I can have thousands of node. I will initially set it all them as 0. Now first of all I need to dry run it, then I will be writing the code, then it will be easier for you to understand. So let's say 1 2 3 and 4. This 1's neighbors are 2 and 4, 2's neighbors are 1 and 3, 3's neighbors are 2 and 4, 4's neighbors are 1 and 3. Right, this is the original. Now how my code will look like, and so first of all I will create the copy of this one. Right, now initially the neighbors are empty. Right now we don't have a neighbor, so that's why we need to traverse in the originals one neighbor. So I came to this 2, and so I will create this neighbor. Right, now before calling the DFS call I need to set 2 into 1's neighbor. I will set it to this. Now I will call a DFS call. Right, now I am at this point. See, I am at this point and I will check into 2's neighbor. 2's neighbors are 1 and 3, and along with that I need to create this one also, the widget vector 0 1 2 3 4. Initially I will set it to null. Now I am at this point, so first of all I will create it, then I will store this address into this, and then I will create the second one, and then I will put this address into 1's neighbor, then I will do a recursive call. Now I am at this point, and now I will check 2's neighbor. 2's neighbor is 1 and 1 is not null, so I will simply put this address of this one into this. I will say 1. Now I will, since I already created 2, so I need to put this 2's address into this. Right, now I will call its second neighbor, that is this one. I will check its second neighbor and it is null, so I need to create that. So I will first create it, and then I will push it into that vector, visited vector 3's address. Now I will check 3's neighbor. 3's neighbor is 2 and 4, so I will start with first neighbor, that is 2. 2 is already visited, so I need to push its address into its neighbor part, so I will push this 2. Now I will check its second neighbor, that is 4. Right, now I will check 4 is null or what. So 4 is null, so I can create 4. I will create 4 and I will push its address into this. See, I am not pushing the values, I am pushing the node, right, the address of the node. Now I will check 4's neighbor. 4's neighbor is 1. 1 is already visited, so simply I will put 1 into its neighbor, and 3 is also visited, so I will simply put this like this. Now I will backtrack. From this point to this, then this, and then this. I am, like, when I started 2, I am done with its first neighbor. Now I need to check its second neighbor. So 1's second neighbor is 4, right, and 4 is already visited, so that's why I simply put this. So this is copy. Now I will simply return copy. So I hope you got my point, and this is the way I will complete that function. So I will follow the same thing. Right, now see, first of all I created this copy this way. Now I need to push this one into, first of all I need to create the vector, then I will push this one into this visited vector. So visited. Now how will I get the index? See, how can I get the index? I have this copy, and copy has two things, value and neighbor. If I wanted to get the value, then I will say copy value. So in that way the copy value will give me 1, so I need to push the address of 1 into index 1. So I will simply say copy. So I am pushing, let's say it has 100x, so I am pushing 100x into this, right? Now I am done with this two things. The first thing, I created this and I push it. Now I need to go into its neighbor. So how will I get, since initially I don't have a neighbor in the clone part, so that's why I need to do a traversing into its original neighbor. So I will say for auto nbr of original one, that is original one. When I say original, I will get the address of this, but I want a neighbor. If I want a neighbor, then I will say original slash arrow neighbor, NEIGHBOR neighbors. So I came into original's neighbor. So before that, before traversing into its neighbor, I need to check which neighbor is null. Then only I can do a DFS call on that. So I will check if visited of NBR, right? NBR of what? And I will not simply say NBR, I should be saying NBR value, because we can traverse in the array with the help of index. So NBR is the address and NBR value will give me the value inside that address. If no, since yeah, right, same, sorry, right, visited of NBR value, I need to check whether it is null or not null. If it is null, then only I will be doing my task. Otherwise, in the else case, what I need to do is if let's say if 4 is not null, then I need to simply push that 4 into one's neighbor. So I will simply say copy is 1, one's neighbor I need to put. I need when I say copy neighbor, it become the vector and I need to push back. What I need to push back? I need to push back the visited of NBR value. See, let's say I am at 2 and if I check 1 is already visited. So that's why I need to push this 1 into 2's neighbor. So that's why I will simply say 1's neighbor is 2, 2's value. So I will since I will came to this point and I will simply push it into 2's neighbors, right, and into this second part. So I will close this, and now when I am done with all the neighbors, then I will simply return that copy. And one more thing is I need to do the task, that is I need to do a recursive call, DFS recursive call. Now first of all, if 2 is not visited, then I need to create that. So node, let's say new node, and I will say new node NBR value. I created that node, I am at 1 and I created 2. After creating, I need to push this 2 into one's neighbor. So I will say copy NEIGHBOR copies neighbor. I will push back this new node, right? Now I will do a DFS call, DFS. Now I need to, since I am done with this, now I am at this point, so I will uh, pass it as argument this 2, and then it follows on, and I will get all the graph done. So I will pass this NBR, since I need to pass this 2, sorry, I need to pass this 2 because we don't have a neighbor right now in the copied part, so that's why I need to pass the original neighbor as well as the new created neighbor and new node, and then I also pass this visited vector. Now all I am left with is just making this function. So I will make this function side y. You will make it above this function. So void dfs node, that is neighbor, sorry, I will say original neighbor, neighbor, and then say node copied neighbor, and then we have vector of node type, I mean pointer type, and I will pass it as argument, as pass by value, sorry, pass by reference visited. Now I have to do my task. So first of all, I told you that whenever you pass it, so after creation you need to push this into the visited part. So I will push it. So visited of copied neighbor value is copied. Now I need to check into its neighbors, so I will check through original neighbors. So neighbor of original name VHBOR NEIGHBOR. Now I need to do my thing. So first of all, I am doing the thing only if visited. I am following the same thing, visited of copied NEIGHBOR value. If it is equal to null only, then only I am doing the recursive call. So first of all I will, and this is my thing, and in the else part what I do, I will say copied, this is the copied 2, so in the copied NEIGHBOR copied, I will say neighbor, copied neighbor, I will push back, what I need to push back, I need to push back the visited of NBR value, right? Now I need to do the same task again that I have done in this. So new node, sorry, node, a new node, value should be NBR value, right? Then after this I need to push it into copied so push back, I need to push back this new node, newly created node. Then I will do a recursive call, like it is inside this only. So DFS of, I need to pass this neighbor and the new node neighbor. new node and visit it. I hope you got it. I will share the code in the description box. So this is how the full code look like, and I think after, and I already discussed this dry run, so you need to do it by yourself, then you will understand how easy is this question, and but it actually enhance your conceptual understanding. So I hope that's all for the video.